review. I think it's called review. To materialize the correct cycle and compare it to the given cycle. Right. So this match function is actually a tad bit complicated. Um, and there's a more clever way to do this. So let's just quickly see if we can fix that, and then go from there. So so match is gonna take list of A and give us back a maybe A. So what we need to do is instead of using chunks of, we just need to take. So we're gonna say let items. So it's like a unit, subunit is going to be I could spell. Okay, so the subunit length is going to be the length of the list divided by n. Hey, Aman, how's it going? Uh, how goes the learning today? It just started. Like literally, we've been here for 3 minutes. So I'm happy to see you today, and we're always hopeful that the learning will go well today, or just generally speaking. How are things with you? I did get a cool new toy, but I haven't been able to set it up yet. So I got one of these remarkable tablets. I don't know if you've seen one of these before. Uh, it's supposed to feel like paper when you're writing on it, but I haven't been able to. Here, let me get the link for you. It's pretty sweet. Oh, I need to fix all the screens. F6. There you go. So remarkable to. Yeah, well, we don't really. I mean, you can just look at this. You probably already found it, but I'm gonna put it in the chat anyway. Um. Oh yeah, I I know that feeling every time. Like I was literally thinking about that today. It's so important to do, and I just don't do enough of it. Um. So the subunit itself is basically take subunit length uh XS, and then basically we'll just build. Yes, we're writing prisms by hand actually. So this particular prism is for a cycle detector essentially. So it allows you, well, it's not a cycle detector, I guess. It allows you to write a prism that can look at cycles. So I'll show you how it works here in a second. But the general idea is, well, this code we wrote last time, which I struggled with pretty hard because it's confusing. But Chris in the answers section had like a really nice example. So I'm just implementing that from my memory, and then I'll go ahead. So I noticed like a bunch of people are watching. So if you've never seen the stream before, um, this is the book that I'm working on right now. It's called Optics by Example. You can get it online from LeanPub if you would like. I don't get any financial benefit, but you get $10 off. So feel free to check it out if you want. And then all the code that I'm working on is available. No, I don't want to copy. I want to copy the link. I keep all this code on GitHub so that you can just check out the results. It's not documented or anything, but it's here. So you can check it out here. If not, you can just watch me painfully not understand how to do these things. Okay, so the sort of correct or result is going to be okay, so we how do we do this thing again? I think we do cycles sharp subunit uh n. Uh oh, I am. Sorry, I guess that wasn't clear. I am working Haskell full time. So I started um a week ago Monday. 2 weeks ago on Monday. Basically November 30th. In Scala, I hate writing type classes instances by hand. I put it on Twitter to be fair, but you may have missed the stream where I announced it. I mean, I sort of announced it on stream, but it wasn't really a big thing. Okay, so we're basically just gonna say, is there a way to just yeah, so I'm working for a bank, Mercury Bank, writing Haskell backend code. That's the plan anyway. I've only just started doing some PRs and stuff, so things are starting a little slow, but I'm getting there. I think there's 40 engineers, something like that. So it's not all Haskell. There are sort of more front end people. That's not right in Haskell. So but I would imagine a lot of the folks do know a bit of Haskell. So I think that this is probably right, but I'm not sure. So let's just try it. Oh, right. So I'm now using like a different uh I'm using Pop! OS for work again because I have a System 76 laptop and I'm too lazy. And then the streaming laptop. Oh, another thing I was able to do recently was update to a bit more RAM. So not that that's gonna help the stream at all, but it's gonna be nice. For whatever reason, I had a really hard time getting it seated though. I couldn't get it seated for whatever reason. The RAM that I took out, I was like, I tried to put it, I put it back in, and it seated just fine. But the new RAM was, I had a really hard time with. Not sure what's going on. It might. Oh, it might help Pascal. Yes, for sure. For sure. And actually, I literally updated it because I was having issues with RAM for some of the larger projects I was trying to mess with. Okay, so what we want to do is hop in ye old REPL. And then what we're going to try to do is match one of these cycles, but I forget the notation we use to. Yeah, so it's like I think it's like derp 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 was the no. Yeah, this was the example we wanted to use. And then you try to view a um first, what is it called? Cycle 3. Oh, import control lens. Yep. So it looks like it works. Um, if we pass it like an empty list, is it okay? Yes. Oh wait, what? How does this work? Okay. So the subunit length. Oh yeah, that's not gonna work. Um, or is this like okay? I don't think it's okay. Is this okay? No, it can't be okay. I feel like that's not the right answer. Um, wait, what? So the length is 0 divided by 3 is 0, right? What did I just do? Oops. I don't understand. What did I do? So if we did cycles 3 make with empty list. You get empty list because it's concat. Hey Chrono, how's it going by the way? Yeah, we use Haskell on the back end. Pretty sweet. It's pretty sweet. Oh, silly me. What am I doing? I guess this is really and. So that should do that. This should do nothing. And then derp, derp, derp. Well, I spelled it wrong. Or scoop, scoop, scoop should work as well. I don't know why I thought of scoop, but I did. So yeah, like we just need to make sure that we don't get empty list. I guess. So excuse me. Um, yeah, I guess this is fine. Obviously we need to do some tests, I think, but to make sure this is right, but no big deal. Okay, so section 9.3, laws. Actually, maybe Chrono, this would help as well. So it's a financial company. So the like correctness is very very important. Um, not that you can't write not that you can't write incorrect code in Haskell, but at least a little bit harder. Um, true. Yeah, yeah. It certainly makes some things harder to do, even on accident. Preview. I said review earlier, but I think the term I was looking for was preview. Okay, so Prisms has several laws, several which we've intuited along the way. They mostly revolve around the idea that a prism is a reversible pattern match. There are 3 laws. So law 1, the review preview law. Review preview law. I mean, it really depends what you mean by more correct. Yeah, I think Haskell is getting revisions to make it, or that will end up being more like Idris. I think that's true. Um, but yeah, like Rust doesn't. I don't know how you deal with side effects in Rust, so I don't really have any comment about that. All right, so if we did, which one's which? Preview and type. I just can't remember which one's which. Okay, so A is or sorry, A. This is review. So if we want to, okay, so if we uh review, in other words, um cycles 3 derp and then we try to preview cycles 3, we should get just value, right? Here's the value. Does that make sense? I feel like Rust is one of those things that I probably should look at some point, but I have some other projects in mind before that. Okay, so yeah, sure. That makes sense. And we just did that. Well, I wrote it in, the shorthand notation, I suppose. Okay, this is a very intuitive pattern for prisms, which corresponds to constructors of sun types, but can be a little less clear for more abstract prisms. Okay. The second law is that for a prism, the structure is completely described by the combination of the focus of the prism and the prism itself. Okay. It ends up shaking out as effectively the inverse of the previous law. Here's a code equivalent. If we preview with a matching prism to get the focus A, then we review that focus A, we must end up back where we started. Hi, Katie. Um, Here, we can say hi to the kitty. Say hi to everybody. Can you say hi? Hi. Get close to the microphone so they can hear you. So, my girlfriend's not home yet, so like really needy. But this is Layla. This is my like 6-year-old cat. Something like that, 5 or 6-year-old cat. She's very cute, but she wants me to pay attention to her, obviously. So she's being a little butt, not a butt. They shouldn't say that. She's a very good cat. So this is kind of like this is review, uh, preview law, and I forget where we are at. We're at Z. So a prime, I think, is usually what I do first. Is like this should be just derp. Okay. And then we have prism complement. Jeez, I can't type. Okay, so we're gonna preview we'll just use the left prism. So we need to have like a left A, right? Um, so this is really S left. I like writing in the shorthand notation. I don't know why. It's probably terrible actually, but it's pretty fun to write. Um, A in S equals S prime. So something like this. What's the issue here? Don't we have two lefts? The other cat wants to be picked up. You ready? Come here. All right. Here's the other cat. Since they're both very needy today, you might be able to hear him in the microphone. Sometimes he'll sniff it and make a lot of noise. But this is Andre. He's like, I don't know, 3 years old. Here, look at the camera. They're cute. All right, what does this say? Um, yeah. So one thing, if you don't know this, black cats tend to be under adopted. So if you're not weird about black cats, adopting one is a really useful thing to do. Um, that's why we got him. And honestly, he's really fun. He's also really really smart. I like was blown away by that. Okay, so basically we need to not blown away, that's kind of rude. Really feed myself on time. Well, yeah, then don't get a cat if you barely feed yourself on time, please. But if you can, I think it's a good thing to do. So this is going to be an either string string. So the idea is I need to specify the different types here. Hey Shogoth, how's it going by the way? I don't know if you noticed this for everyone really, but we surpassed 500 followers. So we're on our way, I guess. It's pretty wild. Bee's Attack was the 500th follower. Bee's Attack. It's a great name. Or a bad name, depending on how allergic you are to bees. I guess it wouldn't even matter, right? Like, if you were any amount of allergic to bees and you actually got attacked by a bee, it would be a bad day. Okay. So, yeah, this should work. I'm actually surprised that this would work even in the REPL, because how would it know what the type of bee is? What would you do with 12 bees? I feel this is a joke. All right. Nice. I like it. Good, Shogoth. If I don't remember, have I seen your stream before? I feel like I don't think so. But if you start streaming and you're doing some sort of functional thing, don't forget to add yourself to the streamers thing. Okay, yeah, then it was before I was even watching Twitch. Um but if yeah, does everybody know about this yet or no? I feel like you should if you don't. So let me bring this up as well. Uh, Declarative. So if you're unsure, there's this declarative programming streams. Speaking of which, I need to just merge this. So I'm just going to do this. Discovered a new streamer, I guess, Matthias. Let's see if this looks right. I see a comma. This looks good. This looks good. Haskell. Nice. Okay, cool. Looks good to me. Merge. Confirm merge. Okay. And then if I remember correctly, we should have a GitHub action running, which should regenerate the README. So we'll see how that works in a second. Anyway, declarative programming streams, please add yourself to that if you are interested in being a part of it. That was kind of a fun thing. We actually used Nix to build a. Wait, why is that not in here? Oh yeah, it's in here. So we use Nix to build this thing, and then we use Nix inside of a GitHub action to regenerate and commit back a README anytime streamers.json changes. So at some point in the future, once this is done, we should get a new commit and it will have the new README on it. And the website, this website should update itself. Oh, that's not good. Ah, that comma can't be there. Son of a gun. Stupid commas. Yeah, I gotta fix this. So first things first, we should just cancel this, and then I didn't see it. That's what I get. So let's just fix this real quick because I'll feel bad if I don't fix it. I think it's in source. Yeah. Pull. Check out fix streamers JSON. Okay, so is there maybe I should also add a check that JQ can like encode and decode this? Will JQ streamers dot how does JQ work? No. Pamac install JQ. Okay, so we're getting a little derailed. So yes, please. So JQ, figure out how this works. Is there just a way to like check? Use tabs, set variable. Yeah, I thought so too, but I'm wondering if I can just be like, okay, yeah, so then it should echo and it should be some other thing. If we do this, whoops, and we do that, then it should echo that. Okay, perfect. So let's do a quick CI. Let me change the I don't care. If people come and they're like, why aren't you doing optics? It's like, well, we got derailed a little bit. Okay, so we need a GitHub workflow build, but this will get copied to GitHub workflows check. Whoops, that's not gonna work for obvious reasons. Okay, and then let's see here. So we don't need to push the changes. There might be. We don't need to copy the README. We don't need to commit anything. We're gonna nix run. Well, let me just do this. Nix shell command and well, anyway, something's gonna go here, I think. All right, and then in default.nix, we need to have make derivation, install phase. What needs to go in here? Can we just like, is there a way to just do a check in this derivation? I don't think I want that here. I think that we just want a shell.nix, which will basically gosh, I always forget how to do this, which is the problem. Shell nix example. Packages make shell. This will work. I think it's basically just this thing right here. No, that's not what I wanted to do. This, that. I don't think this, I think you can just do build inputs and then JQ probably. Because like we only need the pin packages from the README. This should be enough. So if we do nix shell, does this work? What did I do? What's it complaining about? Line 1. Is there not supposed to be that there? I thought. Isn't this supposed to be like this? Whatever. I think we can just do a very similar thing here. Okay. So JQ. And then what do we want to do? I guess we just want to say What? Invalid numeric literal. Huh? That's right, Q. Are we on some ancient version? No? What? Didn't we just test this? What? We just did this. Like a second ago. What's going on? This doesn't mean anything. Line 2. Line 2 of what? There's certainly no numeric literal there. I don't understand what I just did. We literally just looked at this a second ago. And it was working just fine. Anyone have any ideas? Oh my goodness. Okay. All right. So if we just like try to check this, it is time to take a drink. Yeah, it's not echo, it's cat. It's trying to, if we write echo, it's trying to parse. I'm just being a doofus. It's trying to parse streamers, and that's not proper JSON, right? So I'm just being a goofus. Okay, so if we just change the check to Nick's shell, sorry, I gotta get out of here. Nick's shell, and then what is it? Or sorry, Nick's run shell.nix command equals echo streamers JSON JQ. Isn't that what it is? It's Nick's something. Uh, I seriously forget how to do this. Nick's. Oh no, I think it's just I think it is still just Nick's. No. Oh, the kitties are so unhappy. Nick's run example. Ow. Nick's run. Run. Command. I thought it was like. Oh, it's not equals, I don't think. So I think you have to remove this. and then I wrote the echo again like a doofus. Okay, and then it should just work, or it should fail in certain cases. So if we do GitHub workflows check. So we want to run this on any pull request. So GitHub actions run on pull request. Pull request. Pull request branches master. I doubt we'll have any other branches, so that's probably fine. We want to go get our cachex. We don't need this. We just need to run nix shell command cat streamers json jq, I think. And then get status. Okay, and instead of fixing this, let's leave it broken, and we'll look at get status. Get checkout add what do we want to call this? Like add JQCI. Add CI to check if or adds CI check that streamers.json is valid JSON. Okay, and then we will just pull this into master. And this should not trigger any action. Oh, yes, it will. But it shouldn't. Generate readme. I didn't want to do that. But okay. Merge this. Delete the branch. Okay. Cancel that. All right, now we want to entry. Okay, so now we should be able to get that going. Compare in PR. So recent addition, add a trailing comma, delete it. Okay. So at least now I can double check. Okay, so here's our check, and then we'll see if this passes. Okay, cool. So I think we're done there. And let's go back to what we were doing before. So sorry about that, but I need to fix that because it's broken. Okay, so back to laws. So we have our first law, which is basically like a round trip law, one direction, and then we have a round trip law the other direction for a particular Prism and S. So in this case, I guess these lefts have to match, right? Although I guess if I put a right here, it's still nothing, right? Let's check. So if we do B prime or make this right, we should still get B prime. Wait. Huh? Shouldn't this fail? Hey, that's a funny name. Moses supposes. I like that name. It's a good name. Why does this work? This should fail, right? This should fail to have a valid pattern match or something. Why would I get false from this? What? This doesn't make any sense. How? Yeah, so how? How does that make any sense? That shouldn't work. Hey Glass Ethanol, how's it going? How's your day going? That puts us at 501 followers. Very cool. I don't understand how this works. Oh. Sorry. Yeah. So this A is not the same A. That's weird. That shouldn't happen, should it? No, it has to evaluate the oh, interesting point. But I don't think that's the same A. Well, this will verify it, I guess. Um yeah, I guess you're right. Sorry, I'm like being forgetful here. But doesn't it never forces evaluation of the A? It just is saying the right and the left are different, so they're false. That's pretty awesome. Yeah, I think you're right. Uh, YouTube?
Hi everyone. I had an
Oh,
interesting.
nice. Um, I like his videos. They're really good. I'll pin that. Probably watch it. Forgot to pin it though.
Hi everyone.
Pin. Okay. I will look at that later. Shogoth, no worries. Enjoy your dinner. Hopefully it's delicious. Um, thanks. Laziness. Smile. Anyway, we don't really need to write that. We'll just leave this here because what we want is really just true. Um, so that's a prism complement. Excuse me. Um, we use a prism which is unlawful with respect to this law. The show prism normalizes the string representation when you do the round trip. This means the result will still represent the same value with respect to read, but it may be formatted slightly different. Here's a demonstration. So S 1, 2, 3. So no, go away. Ban. Goodbye. Thanks for coming. Bots are fun. The thing that blows my mind about that is how does Twitch not go, oh, B12345 6 is not a real person? Hey Swarm, how's it going? A little bit. But I mean I usually start at like 7:30, so I think I'm almost on time. I started a tiny bit earlier than normal. I'm starting the stream a little bit later these days. Um, which I guess is correct if you think about it. All right, let's see if this worked. All right, so uh, show all checks. Details. Oh, this is actually the wrong name. So, all right. So we should eventually see this. Okay, so now let's see if we can make it fail. So we're gonna merge this one. Okay. And oop, I want to delete that. Okay. And then so we're kind of like multitasking at the moment because I broke something on stream. Um so let's try and break this. Reset. I want to clean up here. Okay, so we can get rid of this, and this. So make break. Okay, so check if CI works. Okay, so we shall make this and we'll see if the CI works. The other thing we need to do, because I just realized that it's incorrect, is we'll edit this and we'll say check JQ can parse streamers JSON and change name of check GH action commit. Okay. Pull requests. CI. There we go. And we'll see if this fails. I hope it fails, because I think that if it returns a non-zero exit status, it will behave as if it failed. And if that's the case, then we're good to go. All right, so C prime. Prism. Well, I don't need to write that. So we're basically going to copy this. Oh yeah. So JQ is just a very simple script that tries to parse JSON. So it's gonna get and it pretty prints it basically. So we have this streamers.json file, and if we feed it to JQ, it will try to pretty print it. However, there's a problem with our JSON, so that doesn't work. If we fix the JSON and then we try to print it, we'll see the output. So basically, all I'm hoping is that if JQ returns a non-zero exit status, that the entire GitHub action will fail. That's what I'm hoping for. I actually don't know that that's going to happen, but we'll see. There's probably a way to force it that it's like a zero exit status because somebody basically made a commit with a trailing comma here, and I didn't notice it with my eyes because I'm a human being and I'm not good at that kind of stuff. But JQ will be able to tell me that it's broken. So that's the plan. Um, the only issue is I need to push up the Nix environment so that this doesn't take like 4 minutes to build. Right? I should just read the Nix shell from the cache, and then that way I don't have to rebuild every single time. So yeah. Anyway, hopefully that makes sense. What is this complaining about? This is kind of interesting. Reduce duplication. Well, I don't really want to do that. Sorry, HLint. I would like to just keep this. Oh, it thinks there's duplication because these two things are the same, which we're going to change here in a second. So 1, 2, 3, and then this is clearly not that. It's just a string, and then this will become show, and then we will try to show a. Right. We're not using this anymore. So it comes from like control. I forget where the prism comes from. Ooh, nice. Perfect. So error. Exit code 4. It shows CI fails. And then we can just go in and be like, boom, it's broken. And we can see why by looking at the check. Expect another array element. Perfect. I mean, it's not beautiful, but this is good enough for me. So we shall close this pull request and delete this branch because it doesn't need to be here. And then let's just go quickly fix this source declarative git not stash reset head hard checkout master pull guess delete that. We already did that. And okay, done. Okay, local development fixed. Next thing is Google. Also, okay, so I didn't finish my thought. Now that we've fixed this, we can look at this app, and it will show everybody who's online. So Andre is online, and James is online. So you can go check out these people and like just go hang out. We'll probably raid one of them if they're still awake when we're done. Which I think James is usually awake, but because he's the East Coast person. But I think it's pretty late for Andre. And anyway, we just added this person yesterday. So you can thank Christian on the Discord, which is also linked on this page. So if you want to join the Discord, you can go thank Christian for building this, and then I'm sort of maintaining and dealing with this list. So we just fixed that, which is awesome. And yeah, we're good to go. Very cool. Very, very cool. All right. Show. I spelled it wrong. This comes from control lens prism, I guess. Oops. Control lens prism. But it seems to think that it's redundant. So what's going on here? Oh, I see. Um, so this needs to be nah. I don't. I hate this. It should just be at string at list int. I think. We need. Okay, it doesn't want to do this, so let's grab type applications, which honestly is probably one of my favorite. Uh, how do we do list of int in Oh, this is probably because of the way show works. What did I just do? Whatever. So it takes a read A and a show A. A is just okay, so this is at list int. There we go. I just looked at the incorrect type. This is given to us um, by the Prism show. So all we need to do is actually get the type class list int here, and I guess this seems to work. So C prime should say false, and that's just because of the way this works. Show has normalized the value to have no spaces between values. Oh, I see. Okay, so it has no concept of like stripping out this, even though they're technically the same. That's kind of interesting. So although these are technically the same, the string representation are different. You know, 1, 2, 3 versus 1, 2, 3. Okay. So, nice. Laws. We like laws. In practice, this isn't usually a big deal. It's close enough. The two values are equal with respect to their semantic meaning, so we'll give it a pass. But if you find yourself failing any of the laws for your custom prisms, you'll want to think carefully about whether your prism makes sense. And yeah, I could see how this one would be a little tricky to get the laws right because we're relying on a bunch of other show representations. Okay. Pass through reversion. What a name. Pass through reversion. All right, I need to shut my door. 1 second. There he is. Hey, welcome identity to the stream. How was yours? We were just looking at you on the FPers Vercel app, which I broke during the stream. Have you seen this yet? I don't know. You probably have seen it. Uh, why can't I copy this? Here we go. No, 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 no. Give me the thing from Chatterino, please. There we go. I broke this earlier, but it's fixed now, which is good. But we yeah, we had an issue, but we did see you were streaming, which was cool. I was surprised to see you on this late. Hey, Imperial Waffle, how's it going? Because I imagine it's like 3 in the morning for you. I don't remember exactly where you are, but I'm pretty sure you're not in the U.S. So bedtime. We are learning about the lens laws in oh, okay, that's not terrible. 140 is not the worst in the world. I wouldn't stream at 140, but I know a lot of people are awake that at that point. Um, anyway, lost my train of thought. We are learning about the lens laws for prisms. Oh no, not, that 30 really does it. The extra 30 seconds can't handle it. Yeah, yeah. I've been. I mean, I really like lenses. Like they're fun to use, but I think that they're pretty tricky in practice, right? Like, and what I mean by that is that the types are really hard for me to intuit. Like when I see prism, like I feel like it doesn't hold meaning yet all the time. Like I kind of understand what a prism is, but if somebody were to show me like a prism without a type annotation, and if I wasn't thinking about it really really carefully, it wouldn't make sense quickly. And then like you have um right, this means something else. Well, that's not what I wanted to look up. What do I want to look up? Yeah, so like, right, that's a type um that looks, quite a bit different than what I think you would expect. It takes like an input of a PAFB and gives you back a PSFT, which isn't as weird as I think the lenses are. If we look up lens, I think it's even more confusing. Yeah, so with a lens, you actually like if the first argument of your lens takes, how do I say this? If the first part of your function takes a lens, you actually have to pattern match out these functions, which are, I guess, like a setter and a getter or something. No, this is a structure. This is, I forget even the terminology. So anyway, I don't know. I find it confusing sometimes, and like it's in the types. If you look at the types, they're there. Just like tricky. I've implemented the lens library from an older paper on stream a few weeks ago. I felt like the paper was more clear than the library. Could you link me said paper or share it in Discord with me so I can look at it? Because I would be interested in looking at it if it would help, or if you think it would help. If you don't think it would help, then maybe it's not worth my time. But um, I know somebody also put together like a implement lenses, like implement a profunctor lenses library. I don't remember exactly who did it, but I'm pretty sure that exists too, which would be useful. Well, that's good to know. Wizard says, I used a C sharp lens library at work a few weeks ago. That's cool. How's the C sharp version of a lens library? I've never even looked. Well, I think I've looked at C sharp. Yeah, profunctor version of lenses. So I think maybe that would help a lot if I did that and like just tried to understand how the types work. And if I did it on my own, I think that would also help, just generally speaking. But I've been able to solve all the problems in the book. That hasn't been an issue. So I don't know if it's that important. Like if somebody asked me, could you do this with lenses? I probably could. I mean, it depends how you're using it, I guess, right? Like we certainly have written some weird lens code. I mean, like I don't know, this is mostly readable to me now. But like what does this really mean? I could see how a lot of people would be confused about what this really means. It's not complicated at all once you understand what the sharp operator and the prefix prism do. but like this is very weird notation to concatenate two strings basically. Okay. Anyway, I do like Chris's book a lot, so I think that's a huge positive in the book. Is the book, excuse me. All right. So, in order to understand this law, which is a weird name, pass-through reversion, we'll first need to develop our understanding of polymorphic prisms a little better. Note that simple prisms built using Prism Prime should always pass this law since they don't perform any conversions on unmatched portions of the structure. When working with polymorphic prisms like Write, to be fair, I've been writing the sort of shorthand versions in like in this last little section. He's using preview and review, so I don't know. Maybe that is more helpful, but I actually kind of like the symbols. But from a developer standpoint, it's pretty much write only. Um, I it would be tough to like come back to this code in a year and be like, yep, I understand exactly what these things do without looking them up, or at least looking at the types or experimenting with a little bit. Anyway, okay, so when working with polymorphic prisms like Write, no worries, take it easy. Thanks for rating and stopping by, and have a good sleep. Um, okay, we can see that we're able to modify the type of the second type parameter as the focus. We're able to modify the type of the second type parameter as the focus. This is a tough sentence. We're able to modify the type of the second argument. I don't understand that sentence. Um, However, prisms also allow us to change the type parameter in the case that we don't match, when we don't match. We can clearly witness this using the matching combinator. So given a prism and a structure, you can either get the result structure in a left or the focus in an A. This combinator witnesses the idea that either we can match on the prism and therefore have access to the focus, or the prism doesn't match and therefore we can change the type of our structure freely into T and return that. Oh, okay. So we're yeah, I see. Um, this is clearly demonstrated using just. So type matching just. I spelled it wrong. Well, I cased it wrong. Yeah, so we're kind of giving it a fallback value, right? This type shows that we can either access the A inside the maybe if it was a just, or we can freely typecast the maybe A value into maybe B because the value must be a nothing. Same can be. Oh, I see. Okay, so it's like if this is nothing, this can just be nothing. That kind of makes sense, I think. So if we had a left, this is totally fine because this B is not there. Okay, this type states that either we have a right value and can retrieve the A, or we have a left and can therefore freely cast the second type variable freely into whatever we like. Perfect. The actual law states that if the prism fails to match and we typecast the structure into a new type, that we can use the same prism to cast it back to its original type. Oh, that's weird. Okay. So D prime. This is a pretty weird law, I would say. Left T matching. What's L and S? Oh, right, we're just testing it. Um, Okay, so we have a left T matching. Can I write this? I don't think I can, but now I want to try. I don't think you're allowed to, but it would be interesting if you could. Well, it seems to work. I've never tried that before. That's kind of interesting. Okay, so matching just S means that the left or the right complement to this left is some B. We don't care what it is. And the same thing is true here. But because we're doing, that's really interesting. Oh, I guess it's because we're going S to T back to S prime is how the B's match. Oh yeah, yeah. This is so like the first one here is pretty standard. Like I've seen this before. But you're right. It's not super common to do this. I just happen to write a lot of type annotations when I'm streaming. It just is a habit of mine. What I hadn't seen before is doing the type of like a pattern matched thing, right? Like typically I would write, I don't know, W and then say W is either uh maybe string whatever. Or sorry, yeah, it's some kind of either. But I've never done it for like a pattern matched out variable like this. Or maybe it's doing nothing. I don't know. Yeah, like sometimes, yes, sometimes that's what I'm using them for. It's like when I have a lot of lets or where clauses and I don't understand what one is, I just start like adding types until it makes sense, or doesn't. One or the other. Uh, yeah, so in this case, the values are trivially equal. However, it's still relevant that the type casting back and forth succeeded. Right. So it's not that we're talking about any b. We're talking specifically about the b being an integer and then a string and then back to an integer. Well, I guess back to a string, something like that. Okay, this makes sense. So the heart of the Prism law is that a prism should behave like a reversible pattern match. Usually it's sufficient to ensure that review my prism is the inverse of preview my prism, ignoring the extra just, of course. Okay, so prism laws. Implement the following prism and determine whether it's lawful. It should match on sets which contain the provided element. Reviewing adds the element to the set should behave something like this. Okay. So we're going to need import data set qualified as S. from list 1, 2, 3 contains 2. Yeah, this makes sense, I think. And then if we wanted 10, we would just like add it. Yeah, this makes sense. Contains is kind of a weird name, but um, sure, I get it. Word A, Prism Prime, set A, set A. Okay, so A, what is A? The thing it contains. So we'll just call it X. And then we're going to build a prism, and we're going to need 2 functions, match and what do we call the other one typically? Embed. Undefined, match equals undefined. I wish the view maybe and I've been calling it materialized, but it's like review and preview. Were spelled out so it's easier to learn. Oh, yeah. So to be fair, I'm purposefully using those to kind of like use them and practice with them. But you can call them preview and review, which maybe is not that helpful actually. But I think that this is pronounced preview and that is pronounced review. I usually say this is like view maybe or something because there's also caret dot, which is like the view. Yeah, you're welcome. Like all of these have names. It's just sometimes it's not obvious which one is which. So that can be the trickiest part. And like I'm purpose or I guess I'm making it harder for you as a viewer because I'm not using the useful names. But if you do have a question about like a line of code, just ask and I'll definitely explain it further because I think I understand what's going on. But yeah, I think we could write this as instead of this, obviously becomes preview, and then this one becomes review. Obviously prefixed. You know that though. All right. So for I think we can use Prism Prime here and it's going to be fine. So what's the type of embed here? We need to be given an A and we're going to make a set of A, I think. No. Let's just look at the type. We have this powerful tool that will do it for us. Um, that's not helpful. Wait, what? Yeah, it takes a set of A to a set of A. So embed will take a set of A and produce a set of A. We have that X right there. So I think it just becomes S dot add. Um, I always forget the names of these things, so I have to go look them up. That's my biggest request of the language and library maintainers for the sake of language adoption. Make it as easy to learn and read as possible without going overboard. Uh, in other words, COBOL. To be fair, I've never done COBOL, so it's not enough for me to do that. Oh, it's insert. It looks like, but yeah, I agree with you. Like generally speaking, X. Okay, so that's embed. Just put the thing in the set. No big deal. Um, and then match is this. All right, so what does this say? We want to find out if set is in, or sorry, if X is in the set. If it is, we want to return the set with it inserted. Otherwise, sorry, we return the set without it. Otherwise, just return the nothing. Okay. So, set case query member. Okay, so this actually gives us a maybe, which is useful. So find the largest element smaller. No, that's not going to help us. We want like just look up or something. Is there no like lookup function without? What? Lookup index, find index. But we really want this to return a maybe. Look up the index of an element. Is there just, why is there no just look up function? Kind of annoying. Whatever. Um, Case is member. Uh, hey Chris, how's it going? Yeah, so member just returns a boolean, which is a little like I just feel like it would be awesome if we could just get. I mean, I guess it's kind of weird to say look up and return the thing that you're looking up in a set. So maybe that is why it's not that way. Um, okay, so if this thing is in there, then we want to actually return the uh like remove or delete an A. Yep, delete X set. False, nothing. I think this is right. Oh, sure, we can just use if. That's fine. Uh, then just else nothing. I, why did it? That was weird. Put this down here. Uh, format, good to go. So, Chris, how are things? I feel like I haven't seen you in a little while. Um, I vaguely remember that you did another lens tutorial or something at a conference recently, and I saw it on YouTube, but it's been a while, so I haven't really thought about it. But I'm finally making the push to finish your book. I took kind of a long break, not because I didn't like the book, I just needed to, or I wanted to do something else, and now we're finally back on working on the book, so it's pretty exciting. The goal is to finish before the end of the year. That's what I want to try and do. Although I don't know if I'll be able to do it because it's quite a lot of content. Like 100 pages in this book. At the end, I guess it's probably going to take me a little while, especially on stream because I'm really slow on stream. Okay, so I think that this will work. Let's try it out. Oops. So import data that has s. Oops. Qualified. Yeah, it's a great. I mean, it's good that it's long. There's a lot of detail and things like this, so it's definitely good. All right, so let's try this. That looks fine. And then if we contains two s from list 1 3. Yeah, this looks good. Okay, that's cool. I mean, that's good to know if I'm trying to like rush it. I think I'm gonna do a bunch of streams between Christmas and New Year's because I have off. So yeah, we should be able to do it. Thank you, appreciate it. Chris, at some point, this is. Let me actually. I'm gonna send a reminder to myself. There's nothing that you need to do about this, but I'd like to know if you have any statistics about people using the link to buy your book. I'm gonna add that as something for me to do. You don't need to do it. I'll remind you in another medium at some point. Um, ask. I think that would be a good thing to know. So, oh yeah, of course. Um, right there. So the first one is the my link for the book. You get $10 off. I don't get anything for it. It all goes to Chris. Well, I think some of it goes to LeanPub, but um, you know, it is what it is. And then the code that I'm writing is available there. All right, so this appears correct. And then what we need to do is test these things. So we're on E. And basically what we want to do is we want to do all the laws. Well, we don't really need to test them. We can just kind of think about them out loud first. But I suppose it would make sense to just try them. So let's do that. So we want this one. Okay, so instead of cycles, we're going to say contains 2 s dot from list 1 3 view contains 2. Okay. So I think that this one's going to be fine. We're supposed to get this back, and we will. One thing I'm curious about is if we change this to 2, because that's kind of a bit weird. No, it does not. Oh, thank you so much. I will. Okay. Well, I mean, it's something, I guess, but that's I was hoping it would be better, but it is what it is. I don't think I could use that as like a way to promote people having me review their books for sure. It would have to be more significant than that. But it is what it is. Okay, so anyway, this lens is unlawful because it doesn't respect the review preview law. That's what it's called? Review preview. Yep. So this returns s from list 1. Yeah, that's kind of what I was thinking is when I was thinking about this. Well, thank you. I'm glad you do. uh, I'm having fun with the book, so I think other people are as well. They also may be buying the book without that link. If like they're like, oh, this is a cool book, but they don't ask for the link, for example. Oh, sure, that's true. Like people that are gonna buy a book are probably gonna buy a book like that very quickly. I imagine like the the sales are very much like a long tail curve. Okay, so no, this is not a lawful lens because it doesn't hold true here. Cool. And then singleton sounds kind of fun. Oh, I don't even have to write it, although I kind of want to. Yeah, I mean that makes sense, right? For I think when I was reviewing Sandy's recent book, I probably generated a bunch more book sales because people didn't know about it and it wasn't out yet. Um, so yeah, I got to your book quite a bit after it was published. So maybe yours is not the right data I should look at to make that justification. Okay. So just for my sanity, I want to put this up here. It's the way I am. So given an A, just put in a list. Given a list of A, do that. Okay, so let's start with F, and we'll basically have singleton. I don't know, A. Singleton. I think that this will be fine. Like I don't see how this would fail. Well, what? Well, okay, this is just yeah, this will be fine. Um, let's just use like 0. Okay. So pass. Okay, and then we don't want that one yet. We want the prism complement. Just grab this code. G prime. And okay, so this one we're just gonna have S as I don't know, integer, I guess. And then just A. Mm-hmm. Yeah, that's actually a good question. Oh, right. So this needs to be like this. And then we're going to say S prime is singleton A, these things. And I think that this would be fine as well. Um, water. Thanks, Mubot. He may have dropped off, Swarm. Um, although the viewer list is confusing. The viewer list is from Chatterino is different than like I don't actually have a viewer list in the Twitch dashboard. I actually don't want to know who's watching unless they're chatting. Like I don't want to out people for lurking. I just like if people want to lurk, they should not have to be bothered. Um, okay, so I think that this is fine. I can't think of a situation where this would be broken. Well, what about this? Yeah. So that is a nothing. And apparently, in this case, we don't have the same laziness luck that we did with the left. But this would return nothing because it's not a singleton. And therefore, well, wait a second. Is this like in the spirit of the. I don't think that this is sort of an example that's in the spirit of the law. That makes sense. But maybe not. I mean, we can see what Chris says about it, but I feel like this potentially is sort of not in the spirit of the law because the structure is not like. I think S is supposed to just be like a list of one thing, not a list of two things. Kind of cheating. Maybe. Yeah. And I was telling Swarm earlier that I tend to use the symbolic versions because I just want to keep practicing with them. So it's more of just a preference, though. It's not. I'm not doing it for a good reason. I'm just doing it. Okay. Let's see here. My feeling is that that's true. I don't know. I'm not sure yet. I don't want to look at the answer. Yeah, I think so too. Okay, so we need to write a prism that fails the first law. Um, basically anything like set or map or whatever else will fail the law for this exact reason. So I'm not gonna actually write one. Maybe there's an easier one. That's a very hard game. I've never actually played them. I know that people really like Dark Souls, but I've actually never played. Um, it's not my kind of game. I don't like the dodgy rolly kind of things. Yeah, Swarm. Even if like it's a good book, it's a very nice book to read as well. The examples are fun, and the exercises are fun. So I would. This is definitely a book I would suggest getting. There are books that I don't think I would suggest that I've read, but this one I think I would, especially if you're interested in optics already. 70 hours? Gosh. I can't. I mean, I don't know. I guess I've played WoW for a lot longer than 70 hours in the past. Well, maybe. I don't know how much I've played since I started the new expansion, but certainly enough. Very easy to lose time in games, but you just got to be it's got to be one of your style. Okay. Uh is it lawful? No, it's not lawful. Fails review preview. Great. Okay, singleton. Okay, so it is lawful, and this is sort of unspirited. I don't know how to say that in like it's not in the nature of the test or um the law. There we go. Do you have any books? Like what books do you have, I guess? Or do you not have any? I wouldn't say that this book is going to teach you Haskell. Like it pretty much assumes that you know quite a bit of Haskell. Um, if you are just so okay, I think that before you start going in a buying spree, you should probably just read. Oh, that's not gonna work. You should probably start with Learn You a Haskell. Like it's not. it's not the best book in the world from a uh like take you all the way to being a Haskell master, but it certainly is great for sort of like getting a feel for all the things that you're used to in other languages. Doesn't cost you anything either, which is super nice. Is there? Oh, okay. So you're beyond that. Um, if you're looking for like well, I don't know, maybe Matt Parsons' book is a good one. Um, I don't think it's finished yet, but this is probably like a recent. Yeah, that's pretty true. Um, this is going to be a pretty recent reference that tries to, introduce production Haskell as a thing instead of like going super deep um in the like the theoreticals. And it's not a terrible price here. I can put this one in here too. I own this one because like I've pretty much bought every Haskell book that I want. Um, So this one might be good, but I think there's like a preview, so you could read the preview before before you purchase. Like I'm not too good. I haven't read this book, so I don't really have a feeling about how it is. I would like to do this book on stream at some point, so you know, kind of obviously the point of the stream or part of it anyway. So we'll do that eventually. Um, I really liked Haskell from First Principles, but I don't really have any references for that. There might be an HP FFP link still from First Principles. Yeah, I think Production Haskell is probably a good reference. It's not done yet, but I know that Matt is working actively on it. Um, I see him updating on Twitter. Um, but I don't know. That's probably a good book. And there's like more specific ones too. Like there's an algorithms book now, which I wouldn't recommend yet because I haven't finished it. But there's too many books, and I haven't finished all of them. I wish I have. Learning Rust. How is it? Is it really similar to Haskell? Because it doesn't look similar from like a. I mean, obviously it's a C-based language, so it's the structure is quite different. Um, but like I was under the impression it doesn't really have like the concept of a monad the way we use it in Haskell. hmm Sure. You can hit me up on the Discord too, or Twitter. I think we follow each other on Twitter. Like if you have questions like that, feel free to ask me at any point. Like I'm 100% can answer that. Um, but I will probably give you the wishy-washy like if I haven't actually read it, I'm not going to tell you spend your hard-earned money on this book. Like I'll never do that unless I've read the book and I enjoy it. I would do that for optics, but I would not do that for production Haskell because I haven't read it yet. I hope that makes sense. Okay, so anyway, we've passed this law. So passes. What is this one called? Prism complement. Okay. And then we have the reversion one. It's weird to say for me. If you squint enough. Yeah, like I just haven't done enough exploration in that language. Like I still feel like I want to get like I just started this Haskell job, so I have a feeling like I'm going to become a little like at least feel a little more confident in Haskell soon. So maybe I'll potentially look at other languages, but there's like so much stuff in Haskell that I still want to accomplish and do. And I also just like working in Haskell. So like why would I switch languages if I have no reason to? um, I guess it's the question mark syntax. I don't know what that is. Never mind. Um, yeah, like I know a little bit about the traits. They're like protocols or whatever those things there. Yeah, yeah, that's true. I'm already learning a bunch about like running Haskell in production, for example, things like this. Okay, so if we want to do this for singleton, we need like list and we need nothing. Oh no, it's gonna be maybe. Hmm. Yeah, I mean, I think that that's generally pretty true. Which sort of yikes. I certainly don't want to learn how to write Java. That's for sure. If I was to pick another language, I would probably pick Rust. It looks the most promising. Um, and like I didn't love C++ when I wrote it before, but I didn't write it professionally or anything like that. But like, I mean, I didn't hate C++ generally speaking. So what goes here? It's not supposed to be maybe, right? It's supposed to be an either. Oh, right, right. I talked about the T. So I think it's supposed to be this. Couldn't match type. Oh, but I need to keep going, probably. Well, that's true. Yeah, that's for sure. You don't want to like switch languages. That just makes it confusing. Unless you, I guess you're working in a large enough team where it makes sense to have like smaller sub pieces or whatever. And it makes sense to write in those languages. Um, yeah, Java will get every feature if you wait long enough. Is that how's that? There's got to be like um, um XKCD about that. Okay, what's going on here? Oh, well, first of all, this is wrong. Okay, so now we're getting this in both places. Um, I thought the whole point was that that B0 wouldn't be an issue. um, so what's so this produces an either, takes a structure S. Okay, so I realized while I was walking away that I think this one is supposed to be actually maybe both of these are supposed to be integer. No. Um, Yeah, so okay. So T is supposed to be maybe list integer. Um so S. So we're trying to match the T. The dude. Okay, go back and look. So trying to match. Ah. So what I should do is do T matching singleton, probably. Okay. So this takes a list of A. So this can't be a maybe, I would guess. And okay. And then right. So T is a list of integer, and S prime is a list of integer because the lefts match. The idea is that the rights are A's, which we I guess don't have access to because we're using matching. Is that how I understand this? Ow. But I'm supposed to do a nothing, so I guess this is supposed to be like this. So the idea is we don't have access to the right. We're using the lefts, and then the the type work goes all the way through. But the type is just list of integer, right? Or it's just integer, which it knows. So do I really have another type here? I don't think I need to pass this test. There's no like complement type. I don't know. Let's see if this passes first of all. Yeah. But like it's not really the same test as this other one, right? Because in the other one there's two type parameters. We don't have two type parameters here. So I guess it just passes and there's no issues because there's no like S and T are the same and A and B are the same. So it's kind of a bad example, I think. Well, not a bad example. It's just it doesn't we probably don't need to test this because the types are all the same. We would only need to test this if we had something like either. Maybe it makes sense. Or a sum type. No, but this is a sum type as well, just recursive. But it has one type variable. Maybe that's the key. I don't know. Unsure. What's it called? Something reversion? Pass through reversion. Reversion. only one type parameter. I guess you'd have to do this for something with more than one type parameter. But anyway, I think it's fine. And then, all right, write your own prism that fails the first law. I'm going to guess that there's just. Oh, okay, that's fine. But basically, anything that is like um, unique on a key. So a map would fail. What else? See if I can think of something else. Um, Certainly don't want to think of an example that fails the reversion law. That one would be very hard, I think. But certainly map would not pass review preview if it was like key, for example. Uh, for this same reason here. I don't know. I can't think of another one. Okay, case study. Simple server. I'll be demoing a few more Prism combinators using a simple web server setup. It'll be a bit unconventional as far as web servers go, but hopefully demonstrate a few Prism capabilities. Define a subtype. So this is 9.4, simple HTTP server. Because I'm a jerk, not a jerk, I guess, but I want to define some new types instead, because you know we're doing prisms and stuff already, so I feel like we should just do this, right? So make lenses, path, body, body, string. Oh, nice. Do I have request in here as well? Post, get, delete. Did I already do this? No, I didn't. Okay. So I already have those made. So good. I was like, what's going on? Okay, but we should have the prisms for requests. There's by no means representative this. Jeez, can't read. Um, Anyway, in which real web server works, but should give us an avenue to explore some concepts which you can then extrapolate into real world use cases on your own. All requests obtain a path that represents path segments in the URL. The request get hosts 1, 2, 3, 4, 5 would be passed into our server as get hosts 1, 2, 3, 4. Okay. Post requests. Wait, what? What does this mean? Sure. Um, this feels weird, but anyway, we'll look at it. Post requests contain an additional body parameter that get and delete requests do not. Since every possible request has a path, I'll build a quick lens for getting and setting the path no matter which type of request we're dealing with. We're going to need it soon. So path, lens, but this path lens is different. It probably will complain in a second. Request path. because this is defined multiple times, I think. So the path is um, the lens for an actual path. So this is going to be request path, I think. I think that makes sense. And then we're gonna have post p body p. Delete p p. So it's right. So setter get p get p setter delete p. Okay, p body. Fun to say. Oh, okay, that's just a typo. It should be a string. Um, I vaguely remember myself writing down some other corrections, but I don't remember where they're written. So I'm gonna have to find them. But let's use my new fancy notebook to write these down. So I have this remarkable notebook, which I'm trying out. Okay. So page 215, chapter 2, or not chapter. Okay. Written down. The thing's pretty sweet. Another thing I probably wouldn't recommend you get because it's wildly expensive. So posts 1, 2, 3, 4, 5. View path. Sorry, view request path. Oh, right. That's not how you build a get. I think. Wait, what? Oh, yeah. This remarkable thing. Uh, it's like a notebook, right? That you can write on. The bird down there, but like it's a it's a tablet, but it feels like you're writing on a piece of paper. It's pretty wild. But like I literally got it today, so I'm still using it, but it's very very expensive. That's why I was saying I wouldn't recommend anyone get it. It's definitely cool, but wildly expensive. Okay, so these P's are paths, which is the problem. So this is really a get path list like so, and then we should be able to get. Yeah, I said that earlier. To be fair, um, I think that's the deja vu. Or well, yeah. Anyway, okay. So post path this. Oops. Oh, it's a post. No. This is a. Problem is, I change all the types and now I'm confused. I'm gonna bring them down here so it's less confusing. I can't bring them down there because of the lenses. So a post takes a body, so we need a body. This is a body. There you go. Okay. Cool. If we have a get like this, there you go. Okay. Um, we could probably also do that, and that would be fine as well. Actually, this would have made some of this stuff a little bit easier, I think. Oh no, it wouldn't. But we could use like the prisms if we wanted to make it easier. Anyway, okay. Well, let's say our super simple server is just a function which accepts a request and returns a response as a string. It's clearly not a book about web servers. Here's our simplest thing that could possibly work implementation. So serve request will be request to string. Okay. So given any of these, obviously. Nice. Okay, so path prefix matching. We're going to have to respond differently depending on which path the request is setting to. We'll want a different handler for get versus get. For instance, let's say we want to handle request routing based on path prefixes. All requests which start with users should run one handler, and post should run a different one. Path prefix is definitely something we can pattern match on. We can also reverse a path prefix pattern match. That's a mouthful. We can also reverse a path prefix pattern match by prepending a path with the prefix. Say that 5 times fast. Path prefix pattern match by prepending a path with the prefix. These two aspects give us everything we need to build a prism. in our yeah, there's a lot of P's. In our particular case, we can match on the path prefix by simply stripping off the prefix if it's there, and failing to match otherwise. We can embed a request into the path by prefixing its path with the segment we're matching on. Here's how it looks. We'll make use of our path lens here to do some of the dirty work for us. So, path prefix string prism request. I'm now genuinely curious. Is there a implementation of a web server that relies on lenses like this? Because that would be fun. Prefix embed match. Like, I can only assume that somebody was wild enough to take this all the way, like, to its logical conclusion, because that's just how people are, and we appreciate it. And then this would be that. So mine's a little bit different just because I have the like everything in new types instead of type annotation. For I don't know, probably no particular reason other than I don't like type annotations, generally speaking. This is interesting. I don't think I've ever done anything like this. Like um use guard syntax for like a partial match, and then this syntax for like a otherwise type match. Kind of interesting to me. I don't know if there's any benefits to doing it this way or just using guard syntax. Um, okay. So we should, of course, test out before proceeding. When viewing through the prism, we expect it to strip the provided path segment from the request if there's a match, otherwise it should fail. Sure. Okay, so get, we'll just use this, and then we want to maybe view a path prefix. Oh, maybe view path prefix of, in this case, posts. What? Um, I don't, I don't understand. Control lens. Okay. Oh, this isn't supposed to be here. There you go. Being silly. Okay. And then if we put something else here, derp, we would just get nothing. Okay, so we're gonna use this to, I guess, pattern match out the layers or something. I don't know if that's the right term, but and then yeah, of course we can run it backwards by I keep saying materialize. Great. So we could have implemented path prefix much easier using the existing prefix prism from the lens library, but I wanted to show you how it works. In future, you can just use prefixed from data list lens. Nice. Altering subsets of functions. We can now pattern match on specific path prefixes, but how do we use this pattern to specify behavior for our server? We need to somehow pattern match on the argument to our serve request function and change the behavior of the handler as well. We're going to do this using an eccentric old Prism combinator called outside. All right. Whoa, that is an eccentric. Okay, so outside. So it's like a lens continuation. Wouldn't that be path postfix? Path postfix. Oh, so okay, so this says yeah, so this is kind of a weird. I think that this is generally a little strange. So let's use this example so that we're working on the same page. Okay, sorry, that. So what this says is I want you to use the path prefix prism to pattern match on our request. If you're able to match the prefix posts, then you'll return the sort of uh, the pattern matched out version of that thing. So if we try to pattern match out path prefix posts from this request, we will end up with this thing. Then if we try to materialize this, so we're gonna say, okay, I want you to make me a path prefix with this response. What it'll do is prepend posts to the path. So it's kind of like it's pattern matching out the prefix component of the path in this case. Does that make sense? It's kind of a strange name. Oh, well, it's kind of a strange behavior, I guess. But that's what it's doing. Hopefully that answers your question. Similar to the above, S to T. Yeah, exactly. So it's kind of like, yeah, you're able to pull this thing out and pattern match, but you're also able to bring it back, and that's what the prism is doing. Sort of a pattern match. It's designed to do pattern matches on, like data constructors, for example. Okay, so outside, it looks like, lens TSBA. Well, no, I think this is a different order. Type prism. Sorry. Info. No, this isn't useful. Info lens. Yeah, I don't know how to make sense of this at the moment. So I'll admit I've never seen this commenter used in a real code-based, practical, or readable way to accomplish the task, but it demonstrates the abilities of Prism well. Okay. So this combinator lifts a prism so that it matches on the argument of a function and returns a special lens. This lens focuses on a portion of the provided function, specifically the part of the function which runs when the argument matches the prism. Of the provided function. Outside combinator returns a lens which focuses the subset of a function which runs when the argument matches the prism. This doesn't make sense, but that's okay. Uh, oh, which part? No, I think I'm confusing multiple things now. Okay, so here's a small demo where we use outside to fix up the unsafe version of tail. So the original tail function xyzy. Yeah, I think when I see an example of it, it'll make sense. No, it's okay. It's okay. Um, it's just like sometimes I can't make the connections that you're making in your head. You know what I mean? So it can be tricky for me to understand sometimes. Sometimes I'm able to, but not every time. Anyway, okay, so tail, disaster, horrible. Here we go. Completely crashes on the empty list. We'll patch it with a quick fix so that instead of crashing, it returns an empty list instead. This means we want to modify the existing tail function, but we only want to change a small portion of its behavior. Specifically, we want to change the behavior of tail when the argument is the empty list. We want to focus on the part of the function which runs when the input is the empty list. Weird. We want to focus on the part of the function which runs when the input is the empty list. Okay. Okay, so we're modifying the behavior of tail when a list is empty. Um set. Or yeah, set. So in this case, because we have a function, we're setting it to another function. That's usually how I pronounce it anyway. Like this is pronounced over, this is pronounced set. You're welcome. Or modify or change, whatever you want to call it. I just happen to call it set. Okay, so we're modifying the behavior of the tail function. That's pretty sweet. Um, did I not save this? Okay, cool. Very cool. Yes. pretty strange, if you ask me, but hmm yeah, it's pretty weird. Um, like, and I guess also, I mean, this is kind of a strange example, right? Because I don't know that this is really the function you want. Um, right? Like, you really want probably list of A to maybe list of A for safe tail, but like, anyway, that's not to nitpick, I guess, but maybe this is the function you want. I guess it depends what you're doing. In this particular context, the types of underscore empty and outside empty take the form. Um, Empty has to return unit. That makes sense. And this is so that it can pass laws, I think. Or well, what else would it return, I guess. Um, and this takes a lens of a list to list function, turns a unit to a function. I think these make sense. Okay. Uh, get back to our server. We're gonna have a custom handler for the user's portion of the app. Let's write the handler we want. That's on with the users. Okay. So oh, I see. We're gonna use over to modify this function's behavior when this makes sense. I see what's going on. So like up here, when we match on this request up here, we'll just say modify these behaviors when these things are true. I guess because we already have the prisms. I see where this is going. Pretty clever. Okay, user handler. This should come from data list, I think. It's not here. So I think this is import data list. Is this it? I don't think we need that anymore. Apparently so. And this compiles, so that's good. Um, Server. Uh, this is kind of fun. And then obviously we can have a posts handler. Does this compile? Yeah, nice. Very cool. So then if we server a we get the user handler. We change this instead to posts. We get the oh wait. Oh, I didn't change the name. That's my bad. We get the post handler. Very cool. Okay. And if we say break stuff, we just get nope, you can't break stuff. Please do not do that. Okay, so see how the path prefix prism not only matches on the argument to determine yeah, but we also get this yep. Okay, so I understand why that intercalate there is there now. I wasn't really thinking about it at first. And then we could have our post handler, perfect, or just start like appending these things over and over again. Oh, I guess this you couldn't put this one before that one, otherwise it would never run. You would only ever get the post one, I guess. Probably. It's pretty cool. All right, I'm getting tired. Mm-hmm. Mm-hmm. We can even split everything under the posts prefix into its own definition. Yeah, which we just did. Great. Matching on HTTP verb. Next logical step is to allow different handlers based on which HTTP verb will undoubtedly want to handle post requests different than get or delete. Yep, we've already derived these prisms, so we just get them. And yep, we just that's sweet. Very cool. I don't want to write all this. There's just a lot of code to copy and paste. Mm-hmm. Sweet. So that's chapter 9. That's very cool. I enjoyed that quite a bit.